Hello, everyone. We're glad you're here. Welcome to our podcast, Foundations, Expert Concrete Training and Adventures, hosted by concretepreneur and industry-recognized expert David Stephenson, and joined by new guests every episode. David has been in the concrete industry for over 20 years as a contractor, operator, owner, product developer, and consultant, and has started, grown, and sold contracting companies as well as chemical manufacturing and equipment companies, and is currently the principal consultant with PCC Consulting. With clients ranging from the NFL to Amazon to the Department of Defense, the largest and most recognized brands have consulted with David for their programs and project issues. Foundations is a free podcast for general as well as specialized contractors, owners, designers and architects, developers, and other concrete enthusiasts who may enjoy and benefit from being a part of conversations David has with industry leaders and some of the incredible people he's worked with over his career. We discuss where the industry has been, where it's going, and adventures to be had along the way. Now, here's your host, David Stephenson, interrupted with the occasional question by me, Rachel Fisher.
Hello, thank you for joining us on another episode of Foundations. Today we have David Jerome as our guest from High Tech. David, can you take a second? Welcome to the show. Can you take a second and tell us a little bit about your company, High Tech, and kind of the evolution of you and moving into that company?
Yes, sir. So High Tech Systems / Progressive Fastening Systems is actually our true company name. Was started in Southern California in the late 1980s by Rick Swanson, who was the sole owner of the company until 2019. The company started with a lot of lag anchor bolts, epoxy injection for the seismic activity in Southern California. And then as most of the building codes got, brought to the point where, they met the standards for any, seismic activity stuff that would take place, earthquake stuff in California, Rick started looking at other options of products to continue to sell to his customers there. And really probably about 24, 25 years ago, started getting into some concrete slab repair with polyurethane products. And then the polyurea 2-component joint fillers kind of came about a little over 20 years ago as well, and Rick took High Tech down that direction. And so that's kind of how we're known in the decorative concrete space, as a manufacturer of 2-component semi-rigid polyurea joint fillers, 2-component polyurethane repair products get used for joint restorations, grout coating, really any type of polished, decorative, or structural repair area. And then in 2005, High Tech started also manufacturing joint pump equipment, and we now manufacture some other equipment as well to speed up the process for large joint filling projects. So that's a pretty brief history of High Tech. I started with HTC, the concrete grinder and diamond manufacturer that was based out of Sweden at one time, one of the biggest names in our industry. I started with them back in 2008. Great start to my career. Met a lot of great people. That's where I met you, David. I think the first time. It's been a while back now. I started with them, and then had this opportunity to come over to High Tech in 2013. I was looking to relocate back to Nashville, Tennessee for some personal reasons for my dad's health. So it gave me the opportunity to come back to Nashville. I really kind of thought High Tech would be just kind of a stepping stone for me, and didn't realize the opportunity that it would provide. So we opened the office for High Tech in Nashville, Tennessee, our second location, back in 2015. And we just recently opened a Dallas, Texas office a couple months ago, and the growth has been phenomenal. And as Rick looked for his opportunity to exit the company back in 2019, he gave myself and 2 other employees an opportunity to purchase the shares of High Tech. So as of 2019, I've been the president of High Tech, and still currently the president of High Tech. And we're just excited for the growth and the things that we've seen in the last couple of years. And I'm sure we'll get into those questions a little bit more here, but that's kind of a brief history. I don't know if you want me to go into any more detail at the moment.
No, that's great. So, you and I met when you got started at HTC. I, at that time, owned American Concrete and Ameripolish, and I can't recall whether I had the sprayer company at that time still or whether we had just sold it. But somewhere right around there is when I met you at HTC. I think you were, I don't really remember, honestly. I've kind of just known you for a while. As far as the exact time that I met you, I honestly don't remember. Do you recall?
I don't recall the date, and I kind of had an interesting role at HTC. I started out as inside sales, and then kind of did some national accounts, and was pretty dedicated to one national account for several years there, and spent many years on the road. So I know we had crossed paths several times, but I don't recall the exact time. I used to assist, kind of help Cliff with the training, just kind of be his assistant during those years, the weeks I was in. So I'm sure it was one of those trainings that we probably had met for the first time.
Getting older means that I don't always remember everything like I used to. Yeah. Actually, you know what? I think I do remember. I think we did a joint training where I was training on Ameripolish and you guys were training on equipment. And if I don't recall where it was. Yeah, I think that was it. But anyway, so as my career is modified and companies have been sold and new companies started, today I'm as a consultant, we manage a lot of specifications. In that capacity, I always put in manufacturers, and so Hi-Tech is always one of the manufacturers that I put in, as you discussed, at the joint fill and grout products during the normal polishing processes, as well as repair, and the repair portions for remodel or projects that have had issues like chips or holes or spalls, in addition to joints. So how long have you been at Hi-Tech? I know you took over as president.
Coming up on 9 years here pretty quickly in a couple months.
Okay. So 2012, 2011?
2013.
2013.
Day of 2013.
Okay. And you said you originally thought it was going to be a stepping stone. That's because you had the blinders of equipment and diamond tooling on your brain, right?
That's correct. I had a 2-year non-compete signed with HTC, so I had was quite honestly going to end up working for SACE is the direction that I was heading, and had a great relationship with several of their guys over there. But because of my non-compete that I had at HTC, I kind of used. At the time, I thought I was using Hi-Tech as a stepping stone to, for income for a couple of years, and got over here and just really, had to realize the opportunity that was in front of me once I was over here. We really started to have some success, and the support I had from Rick and our team out in California, it was the right fit. And when that 2 years came up, I had no desire to go anywhere else, and never knew at that time that I would ever have an opportunity to be one of the owners of the company. Never saw that coming whatsoever, but just really enjoyed being with Hi-Tech and kind of watching the growth. And it's been phenomenal for myself and my family, and been able to help a lot of other people in the industry that I've known that helped me early on over these last 9 years. So that's been kind of a huge benefit that would have never thought when I was making that switch. But you kind of make your plans, but it always kind of you think it's going to work out one way, but it obviously worked out for the better for me staying at Hi-Tech over these years.
Well, let's talk a little bit about that and kind of what led to that. So something I've discussed with several other guests that's always very interesting, and getting different professionals' takes on this is always awesome. But so I know that you guys do other industries other than just the decorative industry and specifically polishing, but polished concrete is exploded significantly over the last 20 something years. I was very early on engaged in polishing. I bought HTC machines from Vic International out of Knoxville well over 20 years ago. And at that time, there was no real industry per se. I mean, I was teaching architects and teaching general contractors, and at the same time trying to figure out how to actually do the work myself, and come from there to where we are today, which in 2020, don't have the 2021 numbers yet, but in 2020, the polished concrete flooring industry surpassed 40% of all hard surface flooring commercially in the United States. So that's a meteoric rise. To give you some perspective, it took ceramic tile something like 40 years or something to hit 20%. So we hit, double the speed in half the time, or double the size in half the time. What have you seen from your time at HTC and then as you moved into high tech? Give me your ideas or your thoughts about the growth of this industry.
Oh, it's been phenomenal. So I came into HTC and having no understanding what polished concrete was. I work for myself as a mechanic, building specialized rotary engines for people and sent them all around the world. Most of my clients were military guys. And then, obviously 2007-8, we had the financial crisis here in the U.S., the housing bubble. We had a change of presidency. A lot of my customers that were buying these cars and high-end engines from me, military overseas guys, their re-enlist pay, these bonuses they were getting got pulled back. Banks stopped loaning on older vehicles. So it really kind of made me look at what my options were. I was recently engaged, having to make some decisions to grow up a little bit. And, I had some car buddies, Cliff Rawlings, Scott Williams, both guys very well known in our industry. And they got me, the inside sales job at HTC. So I came in not knowing much about it. It is a mechanical process with the polishing, and kind of having a mechanic's mindset and understanding polishing aluminum and other metals and things like that. I picked it up fairly quickly and just thought it was a super impressive and neat process. And this was coming out of the financial crisis back then in 2008, 2009. But the polished concrete industry just kind of was really getting its footing, I think, back then. And we kind of still considered that the gold rush years. I mean, it was just still growing very quickly. A lot of huge retail chains in the U.S. were going that direction. They were experimenting with all types of different processes back then. But a lot of retail chains had gone that way, and a lot of them are still doing that today. So I think, the boom has started back then, and it doesn't seem to slow down. Obviously, the retail sector has been affected by the last couple of years of COVID. But all that's done is just make the industrial side take off even stronger. And we see more decorative concrete in the industrial side. Obviously Amazon and Walmart facilities buying up any and all property that they can has been great for our industry the last couple of years. It's definitely created some challenges with COVID, with the supply, and there's a lot of other things that have contributed to that. But overall, the industry is booming. I would have never thought when I started with HTC back then that it would continue to go this direction. I think a lot of people felt it was kind of the new fad, and didn't quite realize, just those stats you just shared with us. That's phenomenal growth in such a short amount of time, and we're seeing it specified and utilized in more and more applications every single day.
Well, the prior kind of fad that led me to start trying to work on dye was acid stain. And, so if you remember, this would have been before you went on with HTC, but when I first got going as a decorative concrete contractor, I was doing acid stain floors. So acid stain, then a clear sealer over the surface, and concrete overlays. So like pool decks or driveway reconditionings or sidewalk reconditionings and things like that. And so when I first got my grinders, the first grinders that I used were red HTC machines from, way back in the very beginning. I think they were some of the first few that came to the United States. But I first got that equipment not as polished concrete equipment. I got it as prep equipment. And so I was using it to prep for epoxy or prep for overlays. Actually, I'll tell you kind of a funny story that was the tipping point for me on dye, but it's funny, and you'll appreciate it when I tell it to you. So acid stain is a chemical reactive colorant. So it has metallic acids that react with the concrete and change the color of the concrete itself. But it's very finicky. easy to mess up. So we were doing basically a mansion for one of the wealthiest people in the country. And everything was perfect. I mean, we dealt with a GC, we dealt with all the subs, we dealt with everything, and everything was just perfect. We went in, stained the floor, applied the acid stain. It was all through the entire first floor of the home. But there was a huge entertaining area that was like a library or a den or something like that. And that's where all the parties were going to be. And that was like the focal point where everything had to be right. And so we applied this acid stain. We finished at like noon. Every other sub was out of there. Nobody was allowed to be in the house. Shut everything up, locked it off, left it overnight for it to chemical react. Came in the next day, and I see the floor was like a saddle brown color. And I see this big puddle of like chartreuse and greens and yellows, and just looks nasty, horrible. And then you start looking around, and there's like little paw prints everywhere throughout that whole big important area. What happened? Security footage, an electrician got there, opened the back door to see if anybody was there, saw the caution tape across the door. So he shut the door, but it didn't shut all the way. And a raccoon got in there and just decided to walk into the middle of that room, take a big leak, and then proceed to walk back and forth through it all over the place. And so just that little bit of urine destroyed the chemical reaction, and there was no way for me to salvage it because I couldn't put any color back because the chemical reaction had already happened. So they ended up having to cover that room, which was a devastating blow to them, and the homeowner was pissed, and it was a big, very frustrating thing. So that was one of the situations that led us to start trying to push to understand concrete dye, because it wasn't chemical reactive. So that fad luckily passed, and then we got into polished concrete. And I think because of maintenance and general green building and the overall appearance, I think has led to its strengths. What do you think?
No, I agree 100%. So I think the durability, that was one of the things, starting at HTC in 2008, and then, it was kind of being sold by some manufacturers out there as a maintenance-free floor. We all know that's not right. Definitely is some maintenance involved. But I think over time we've proven that the maintenance cost is very minimal compared to other options out there. And one of the brilliant things about it, and obviously a little different from your story, but now that, with the dyes and with the mechanical polish, it's an easily fixable application in a lot of ways. Where if there is a mistake made or some damage done, there's so many different newer technologies these days and ways to blend stuff in and repair that. But the overall durability is phenomenal of concrete. And that's why it's used at the volume that it's used. And I think that's going to, continue to be, there's beauty in it, there's simplicity to it, and there's so many options and so many ways to go back after the fact and repair some of these issues that arise with minimal downtime. And so it's, I think there's so many reasons that's led to polished concrete continuing to just kind of take over. Not just here in the U.S., but, the great thing to see is the continued growth worldwide as we learn more and more, as we look at international and our different opportunities out there, as we're really continuing to see polished concrete take off all around the globe.
I travel all around the world managing projects or fixing problems. So I can attest to that. Asian markets are exploding, and the surprising one to me right now that I've seen is the European market. So all this equipment that we use came mainly from Europe, from the tile and natural stone and terrazzo industries, and was modified. We did change the equipment a bit some to make it more viable for concrete, but that's where the machinery all came from. But now it's almost like, as Americans, sometimes people say, we take somebody else's idea and we figure out how to make it bigger and better, right? Or at least bigger. And I think that's kind of the situation here. We took equipment from the stone industry, turned it into concrete equipment, and now the people that we took it from are back now using it the way that we figured out how to use it. And they're doing a lot of polished concrete throughout Europe now, especially in old buildings. You can polish a 200-year-old slab and make it still look pretty cool without taking it out.
Yeah, 100%. And, one of the things that, and I agree with that 100%, because we kind of saw, working for HTC being a Swedish-based company, all the polished concrete that I would see when I would take my trips over to Sweden is they would do large aggregate exposure. And they called it the poor man's terrazzo at the time. Still an absolute beautiful floor, but it's a very labor-intensive process to get to deep aggregate, consistent aggregate exposure. And that's what led to the remote control, the different regulations as far as labor, and that led to the remote so the guys could work longer, less, shaking, vibrations on their body. So many different things came from that. But then the machines came to the U.S., and our polished concrete here is a completely different mindset. Typically, we don't see, especially on large scale, we just don't see a lot of full ag exposed concrete. We're much more salt and pepper production rates. And we modified the equipment, and we're still seeing the equipment get modified today. I mean, the power trowels are a prime example. And there's a contractor here in Nashville, Tennessee. I will not share their name right now, but they were polishing with power trowels back in 2005 or 6, before I was ever even in the polished concrete industry, on some of the big home supply stores here in the U.S. And, they kept that they had figured out the system back then. They kind of kept it secret, and probably wish they maybe would have shared that back then. And I'm sure there was a big money opportunity. But we can kind of continue to see the U.S. market view how we can increase production while keeping quality up. But so it's a little different mindset. And then we really see the U.S. market, and you and Ameripolish is a great example of really pushing the densifiers, the dyes. That's something that, coming from the European market, we didn't get a lot of that education over at HTC from them in Europe. That all came here from the U.S. guys to kind of say, hey, we have these needs, we have these issues in the industry, and these are what we face, and we found the solutions here. And it's pretty neat now to take our solutions from the U.S. back over into the European market and show them, hey, this working with concrete, this is what you can do to strengthen it and do more decorative and give long-term better service to the end user of this floor by using these products. So that's been really neat to see over the last 10, 15 years.
Funny observation. I kind of have a theory about everything is more valuable the further away you get from its source. So, example would be like Mercedes-Benz. Mercedes-Benz in Germany is like Ford. They're the taxis. Everybody's got one, right? Not a big deal. But in the U.S., Mercedes is a higher class automobile. Even though it's the exact same model that you can buy for half the price in Germany, they'll double the price and sell it here as a luxury item. Well, same thing's kind of for us. When I teach a class at a convention or something here, maybe I get 50 people, maybe I get 100 people. Rarely, I have a couple hundred people in the audience. When I go overseas somewhere, that's the exact same class, teaching the exact same information, and I'll have hundreds of people in the audience. It's like they'll come from, all over the region to come listen to a presentation about the same thing that 50 people want to learn about here, 500 people want to learn about it overseas. So I think that, especially like for you guys, I think there's opportunity as a manufacturer there's a lot of opportunity overseas, because you can end up selling a lot more product, even at a higher margin, because it's more valuable because they don't have it.
Yeah, we agree 100% with that. And the challenges we face as a chemical manufacturer is, there's some REACH certifications and things you have to have. And in certain parts of the world, they really want you to share your full formulations. So that does create some issues. But we continue to see, and we've not put, as a company, we've not put near as much effort internationally as we should have to this point, where, there's still a lot of opportunity for us here in the U.S. market. And I think, Hi-Tech's a well-known name now. But there's still a big gap between us and our two largest competitors. So, but there's a ton of opportunity in Europe, and that's something as we move forward and internationally as a whole that we will continue to explore. And so far, we just kind of utilize our relationships that we get at World of Concrete, and our distributors that we use internationally help us overcome some of these challenges to move material around the globe. And the last 2 years, that's been a bigger challenge than ever logistically. With what the world is facing right now. But, huge upside international. And, we've seen a lot of success in the last couple of years with New Zealand and Australia, Japan, well, and we keep hearing more and more about the Asia as a whole, that market just exploding. And yeah, it's been fun to watch, and it makes you feel good that, hey, we kind of, I wasn't in at the very beginning of this, but I've seen a huge development with polishable overlays, densifier technologies changing, guard technologies changing, dyes, all of that just in these last 15 years. It's I have a lot of pride when you get to go over and be involved with that and kind of show them that, hey, we didn't start with this technology, but we've definitely helped advance it, and I think it's good for everyone as a whole.
Well, you kind of bring up a point and made me think about something I wanted to ask you about. So, as we discussed, the industry, especially specifically the polished concrete industry, decorative concrete industry, has really exploded a whole lot and really fast. And I think with anytime you get really fast growth, you have growing pains. The growing pains that I see are that honestly are why I'm even in business as a consultant, is it seems like as the industry has exploded, there's a whole lot of, for lack of a better term, kind of Wild West action going on. There's a lot of contractors that never get trained, that never get certified, and really don't know what they're doing. And they go out and kind of sell that they're doing polished concrete, which is, and it may be a light grind and then multiple coats of a topical stain protection or something like that. And they'll call it polished concrete because the general contractors and the owners don't really know the difference between a good mechanical finish and a chemical finish. And I just wanted to see, for you guys at Hi-Tech, how do you maintain or how do you manage your control over your product installation and the contractors that are installing your product? How do you manage their training, or do you do certification? How do you manage that? That's my question.
Yeah, so there's multiple ways to go about it. So we try to do trainings as often as possible. We team up with different grinder and diamond manufacturers, different people in the industry to do these joint trainings. So that's one avenue. The Hi-Tech model, and for right or wrong, for how everyone in this industry wants to go about it, we are very heavy in the field. We're very on job sites. We don't have a sales team. We just have guys that truly understand our product and the process, and they want to go out and they want to train. So you do the best you can to educate and train. COVID has created a very unique challenge in the labor market. And it's always been tough. These jobs are mostly a lot of it's retail work. It's almost night shift exclusively. There's a lot of guys who can make great money in this industry, but it is a life away from your home a lot of times, and that's not easy to manage with personal life sometimes. So we've definitely seen in the last couple of years where we're on job sites and some guys, they're just not trained, and it's because you just have to have bodies. The growth opportunity, that the jobs are there. It's not slowing down. This industrial boom is just unreal right now with these large box buildings. And just trying to get employees and, someone with true knowledge in our industry, their value is skyrocketing right now. If you're a guy in the field with a work ethic and knowledge and truly, just a good can-do attitude, you're very valuable right now. And will continue to be very valuable. So we do a lot through trainings, but, one of the things that you were kind of asking there is, trying to get the education up to people to understand. The first question I ask in any training I do, and this is very specific to the joint filling side of things, is why do we fill joints? And almost every single response that I get right off the bat is, to seal them off to keep dirt out of them. And that is the case on a lot of exterior joints to keep water from getting down in there. You're truly trying to use a sealant to seal them off to prevent freeze thaw. But on an interior joint, expansion contraction joints, we're filling those joints because we need a transition strip from one piece of concrete to the next. So if there's any cart traffic or fork truck traffic or anything going over, it doesn't start to damage and spall out the edge of that joint shoulder. And most people don't understand the difference between a sealant and a semi-rigid joint filler. Actually, the biggest thing we deal with here at Hi-Tech today, whether that's an architect or a GC, most clearly just don't understand there's a massive difference between those two things. So we spend a lot of time trying to educate people and explain adhesive and cohesive separation so that they don't call that a failure. Quite frankly,
right.
It's just not. Go ahead. I'm sorry.
No, I was agreeing with you.
Yeah, so one thing we hear a lot is, the joint failed because there's some separation. It's like, there's just not products out there that are hard enough to hold up a fork truck and not depress and deflect underneath a fork truck traffic, that can double and triple in size. And with, the construction schedules that we all see, in a perfect world, it used to be let the slab cure for 180 days, have it fully air conditioned and acclimated to its final operating temperature for a minimum of 14 days. That's not reality these days. So most of the time when our contractors are being asked to fill joints, the doors and windows aren't even in. I mean, hell, the whole roof's on. That's a plus. And, we refer to ACI standards, which is now says, 28 days after the slab is poured, it's okay to fill joints. And, we will agree with the ACI standard on that, but the realistic is, just being realistic, that there's going to be separation because the slab is not fully hydrated and cured out at that point. And there's just not products that are that hard that can stretch that much. Any softer product with more elongation is going to depress and deflect underneath heavy fork truck traffic, which then doesn't protect the joint shoulder. So, it's been an evolution from the epoxies, which were the first out there as the joint fillers in industrial slabs and really any interior concrete slab. The first semi-rigid joint filler out there were the epoxies, and those are great products and had a great run. As the polyureas have become more kind of the primary semi-rigid joint filler out there, they do have better elongation, but they do still have limits. So that's the constant biggest education piece for us at High Tech, is explaining that the earlier we fill these joints, when there's still moisture in the slab and as it hydrates out, it's going to continue. And not to jump around too much here, but when you're talking about a slab in Minnesota where there's a ton of water and humidity in the summer and 95 to 100 degrees, and then you get negative 20-degree nights in the winter, I don't care if the slab's 30 or 40 years old. It's still moving. It's always going to move.
Right.
That's just
hard to manage that spread.
Correct. Yeah. And just making sure people understand the difference. We still see sealants specified all the time inside large industrial facilities. And, a sealant's a very soft, typically single component product. It will sag. Any sharp object will poke right through it. It's not much harder than bubble gum. But it does seal off the joint. It will stretch a lot. It can double, triple its size, but it offers no joint protection with any load passing over it. So just that education point is the toughest. And I don't think we ever get everyone educated on it. We just continue to work at it and try to explain. And most, when you break it down to simple terms, they understand pretty quickly the difference. And then it kind of helps set the expectations of what's realistically going to happen with these rushed construction schedules that we all face today. And that's the same thing relating to power trowel polishing. I mean, we get the question, even back at HTC days, we get the question all the time, 12, 13 years ago, is, how early can I get on the slab? And, the standard says 28 days, but there's all types of systems out there that now, concrete technologies that retain moisture, and you can polish them in 3 to 7 days. That's just the kind of the U.S. construction schedule that we face, and those create challenges.
Well, I will tell you that for the longest time, for probably 5 years, and this is going way, way back, everybody would say, and the manufacturer of the equipment and diamond tooling, everybody would say, you got to wait 28 days, you got to wait 28 days, you got to wait 28 days to do anything. I kind of pioneered or figured out that, especially on like schools, I was doing a lot of schools a long, long time ago, and schools have a lot of walls. They have a lot of doorways, everything else. And if you wait 28 days, well, heck, half the walls are studded up. And so what kind of figured out is that I could do the grind portion. So anything up to 100 resins, do all that before the walls go up. As long as it's been down for 14 days, I can do the grind. But as many times as we tried it, which is probably, I don't know, give or take 100 projects, if you went above 100 grit resin into the polishing kind of portion of the work, that would all be waste. It would all disappear. It would all go away. You could watch it. You could do a sample on Monday, and it tests at 60 gloss. And on Tuesday, it would test at 50 gloss. And on Wednesday, it would test at 40 gloss. And by Friday, you couldn't even tell that you put a polish on it at all. So it could turn out to be a total waste of money and labor to go do the full polishes, but we could get that grinding done before the walls go up. And as you know, it's a lot easier to hand polish that it is to hand grind a slab. Trying to get, small diameter hand grinder to cut the same as a big machine is impossible, right?
Yes, sir. 100%. Yeah, that makes a ton of sense. I mean, if you can get on it early, definitely, like you said, for the grinding, and obviously, you can get in there before the walls go up. You get as far along as you can in the process. Just understanding the expectations of what that can cause as the slab continues to cure out and start to get some craze. And if you're beyond the grout coating process, you do that work, and then you realize, okay, now it's got craze cracking everywhere from the hydrating out, and now I've got to go back and grout coat. It's like, man, I just ran a lot of hours and steps there that now I've got to go back and basically redo to remedy this issue. But yeah, no,
that's why you do big samples, right?
Yes, sir.
So let me ask you this. What is your best selling grade polyurea?
All right. So, our PE85 is what we've been known for the last probably 6 years. We were the first manufacturer to advertise a moisture tolerant joint filler. We weren't the first to have it. We weren't the first to have it. We were just the first to advertise it. So, just like some others advertise UV stability, that they were the first, and these are all aromatic polyureas. So whether it's us or any competitor out there advertising UV stability, any of these aromatic polyureas will color shift over time with enough UV exposure. But the colors that we see for a new construction that we probably sell the most of would be a color called grizzle gray, and that's on the Sherwin-Williams color chart. We have no affiliation with Sherwin-Williams whatsoever, but we do use their color chart and match a lot of our products to that color chart because it's very simple for anyone to run down to a local Sherwin-Williams, buy one of their fan decks for $10 or $12. I'm not sure what the going rate today is, and match it to a floor, and they give us those colors. So one of the growth that really started with Hi-Tech is because our competitors would offer 12 or 20 colors, and one of our big competitors only offered 3 colors years ago. And we would tell everyone, if we can see it, we can match it. So for our joint fillers, we have right at 500. I have to see the latest count on what we made.
Wow.
We've got right about 500 different color options for our polyurea joint fillers. We have just over 400 colors for our leading repair product called our Spall TX line and TX3. And then we have another, 4 or 5 different products that each have anywhere from 30 to 100 different colors. So we've got somewhere around 14 to 1,500 different color formulations for our products, which really helped us grow back in the day. These days, it makes it a lot tougher to manage. I wish we could maybe reel that in a little bit, just from a production standpoint. As our scale continues to get larger and larger, it becomes, we still will match custom colors, but these days I take more of the mindset of, hey, we've got 500 colors of joint filler. Could you please pick one so we don't have to formulate a new color? But we still offer that service. But as we've gotten larger, it becomes more difficult to do those custom colors, unless it's for a large project. And of course, we'll gladly do that for somebody.
So you said your 85 is your best-selling joint fill currently. Can you, for our audience, give an explanation of the numbers of different joint fills and what the numbers mean?
Yeah. So the 85 stands for the Shore A hardness. So there's a Shore A scale and a Shore D scale, which different types of rubbers and plastics are basically measured on. The Shore A scales are more for a softer product. But I don't want you to think soft, because it ranges anywhere from like a product like a sealant is typically a Shore A of 25 to 40. Very, very soft, like chewed up bubble gum. Very, very flexible. Our 85 is, we call it 85, but it's actually about an 85 to 87. It varies a little bit on the Shore A scale. So it's a little bit harder than a fork truck tire. Typical fork truck tires are somewhere around an 80 to 82 on the Shore A scale. So you have this Shore A of 85 to 87. So when the fork truck tire goes over it, the tire will deflect and not the joint filler. So we offer a 65 Shore A product called our PE65 MI, meaning moisture intolerant. I do want to back up on the moisture tolerance here, because all of us manufacturers today have moisture tolerant joint fillers, and they're great. And the reason behind the moisture tolerant joint fillers is we have a lot of contractors doing retail polishing for different grocery chains in the U.S. And as they started to put the sprayers in over the vegetation sections, and then you also have these different freezers which would thaw and have some water run off. And then, of course, there's auto scrubbers being ran in these facilities. So what would happen with the original polyurea technologies is they would contact the water, it would off-gas and swell, and then when you would shave it, it would look like a sponge. It would not be a good solid surface. And really the material just did not like water. So we came up with a formulation back in 2014, I believe, that could handle...
Pause one second. When you say it looks like a sponge, when I look at joint fill that was not moisture tolerant, where there was liquid or moisture remaining in the joints, it would, when I look at it, and this is more for our listeners, you look at it and it's got tons of little small air void holes where the product, while it was still liquid, I think, you can tell me if I'm right or wrong, but still liquid, outgassed on the bottom, and then the air voids traveled through the wet product all the way to the top. Because I've taken like a needle or a sharp paper clip or whatever, and I can put it into those holes, and it's like they go all the way to the bottom. Is that what it's doing? It's gassing on the bottom and then traveling through the wet material to trap that air at the top, and then when you shave it, you have all those air voids exposed?
That's exactly what's happening. So these aromatic polyureas and polyurethanes, it's a thermal reaction when they cure. So what happens is you shoot and polyureas are very quick, and we pride ourselves in having one of the longest open times of the main manufacturers of polyurea joint fillers out there on the market. But when I say we pride ourselves on having one of the longest open times, that's only 45 to 60 seconds, depending on the temperature, because the temperature of the material stored out, the slab temperature, the temperature there, that all depicts or changes how quickly the material will cure. So what happens is you shoot this polyurea into a joint, and it goes down into the joint, and then if the joint is activated, if there's a crack, when I say activated, I mean there's a crack at the bottom of the joint did what it was supposed to do. It controlled the cracking to right below the joint area there. So that polyurea will run down through the joint, and even in plenty of applications years ago, the joint looks as dry as could possibly be, but if there's any moisture underneath the subsurface there, what would happen is the polyurea would go down through the crack, it would hit that moisture, and then it would off-gas, and then air bubbles would rush to the surface. But because it's a thermal cure, the top surface cures quicker than the bottom of the joint, if that makes sense. So you've got the most heat there at the very top of the joint, so it kind of skins over while the material below is still in liquid form. So given our products more open time, it gives it a better chance where if there is a moisture for those air bubbles to get to the surface and go ahead and break the surface before the skin cures over on the top. So when you shave it, you don't have pinholes. There's a couple different ways to get around moisture. You can do it chemically, which is the option that we did, and it took a long time to do, or you can speed up the joint filler so it has less time to react. And speeding up polyureas and polyurethanes is very easy to do. Slowing them down is very, very difficult. They're very quick curing chemistries. So that's the challenge is when you shave it, you see all these little pinholes. And when you have all these pinholes, the material doesn't have that same shore hardness. It's much spongier. It looks spongier. It is spongier. And then it can't do its job. And, speaking of the moisture tolerance, that still doesn't mean Hi-Tech or any manufacturer out there is going to recommend that you fill joints with standing water. Or if you're saw cutting out the joints, if there's standing water in there, we don't want that either, because what happens is when you're saw cutting that joint out, you're giving the joint sidewall a nice profile. While there's moisture in there, now you're turning that concrete into a slurry, and then that slurry will cure to the edge of the joint wall, and then you vac out. There's not much to vac out at that point because it's mostly slurry that's cured inside the joint. So then you shoot your joint filler in there, and then the first time a heavy fork truck or something goes over it, the polyurea is not bonded to the concrete, it's bonded to the slurry, and then the slurry will break off of the joint sidewall, causing the separation. So we're always very cautious. We tell people, yes, these products have moisture tolerance, they can handle moisture, but it's really only for in a situation where, let's say you have a 3 or 4 foot section, that you had a roof leak, some water come in, you do your best to dry that, or if you're in a grocery chain and they've got the vegetation sprayer, there's some light moisture. But none of us, myself or any manufacturer, is going to recommend anyone put these materials down in a truly wet joint, because it has to displace the water for one, which will run the water up the sidewalls of the joint. So your bond will never, it'll be a bond breaker. You never it's something that was needed, but we also don't want to advertise it's something that you should do on a regular basis. It was just something to kind of cut out some of those issues, because as polyurea has become the primary joint filler, it has so many advantages over epoxy joint fillers. The one disadvantage it has is when you make a mistake with polyurea joint filler, much more difficult to cut out of a joint than the epoxy is. The polyurea heats up, kind of turns into this sticky cotton candy type looking material. Just not a good product to remove out of a joint. So we tried to eliminate, having that spongy look, where in these retail chains, obviously the contractor would have to go and cut that back out. And there is no fast, easy way to remove polyurea once it has cured.
Sure. So I want to recap, and then I bet you can probably guess where I'm headed next with this. So you have, really soft polyureas or really soft joint fill materials at like a 25 shore hardness. And you have your more rigid polyureas at an 85 shore hardness, which is great for manufacturing and forklift traffic and stuff like that. In the specifications that I control, and I know you and I have had this conversation a bunch, I tend to put in, if it's an industrial facility, I'll specify the 80 shore hardness product, because to your point, exactly, everything, it's rigid, it maintains the integrity of the joint, and they don't deteriorate and spread and break with forklift traffic or pallet traffic. But a lot of the accounts, especially the retail accounts that we manage, they don't have much, if any, forklift traffic, and most of what they have is either foot traffic or light carts and stuff like that traffic, with people buying clothes or groceries or whatever. And so I usually specify a 60 shore hardness product in there, because as I understood it, an 80 shore hardness has, say, 20% elongation. Is that right?
Well, that's a great question, and I know where you're leading here. So yeah, the 65 that we have, 60 different polyureas, the ones that are in that 60 shore, they do have better elongation in the joint, better stretch. Here's the real problem, and this is another expectation people, architects and GCs all the time, is the testing that we're held to, the ASTM testing, and I can't remember what it's I can't remember off the top of my head which one the elongation test is. I apologize, but the testing that we're held to, they require us to pour a mold that's about 6 inches long with our polyurea, and that's about a 1/4 inch deep, and they put it in, it's in a controlled environment. The temperature set at 70 degrees in the room. They put it on this machine, they clamp it in, they mark 2 spots, and they stretch the material until it breaks. Keep in mind, this is a 6-inch piece of material that's right at roughly a 1/4 inch deep in thickness. So absolutely nothing like what happens in a joint. So we get these elongation tests, and our 85 is around 150, 170%. Our 65 is around 220, 240% elongation. So the architects and GCs see these numbers, and they go, okay, well, that 65 can double in size. It's showing 200% elongation. It should be able to double in size. Well, it's kind of like taking a phone book. You take in 20 pieces of paper, you can bend it, you can flex it real easy. You take, something 500 pieces of paper, it doesn't bend and flex so easily that way. So the test that we're held to is just not realistic to what happens in a joint. And then there's really no good way to test the way that we're doing in a joint. In a joint, we're typically filling the material a 1/4 inch wide, but it's 1 inch deep. So
right.
And there's all or 2 inch deep for a full depth fill in the industrial setting. And there's, Metzger McGuire has been a leader in our industry for a long time on our side with the joint fills. They were the first to do the epoxy joint fillers, and they're a great educator, great competitor to us here in this market. And they heavily promote full depth filling in industrial, meaning that whatever the depth of the joint is cut to, you fill full of material. And there's the reason they do that, because if you do have separation on both sides of the joint, you don't have any opportunity for push down, because the ledge at the bottom of the joint, the shelf down at the bottom of the joint, the material is resting on. But then you have other people, one in my own company here, that there is some merit to not going full depth, because now you're bonding to just 2 joint walls and not the bottom shelf as well. So you get a little bit better elongation. So, this is a topic we could probably discuss a bunch, and it's the toughest to educate people on, is because the tests that we're held to by ASTM standards that we all advertise about is simply not realistic to what happens joint when you're filling a joint a 1/4 inch wide and 2 inch or 1 inch deep. The real elongation is probably somewhere closer to that number that you mentioned, and that 15 to 20% is probably the true elongation. Because think of it too as a sealant, or any, the Stretch Armstrong toys everyone had as a kid. When you stretch something like that, it's going to start to sag in the middle. Nothing is going to stay perfectly flush as it's stretched. So once it starts to sag well below the surface, it's really not doing its job either way. It may have sealed off the joint. And that's what you see with sealants and exterior concrete parking slabs. Yeah, they're there to seal the joint off to keep water from getting below. But there's a huge, concave area in the middle of the joint that if you had a hard tire impact going over that joint, it's not offering any protection to the joint shoulder, but it is keeping moisture out. So it's a constant education of what these tech data sheets say, and we have these testing to show these numbers, but unfortunately it's just not super realistic to what really takes place on a job site.
Well, so I'm going to take advantage of the fact that I've got you trapped on this call to to get your thoughts and buy-in. So when I specify, or when my firm, when we specify write specs for programs or projects, you guys have your own internal testing at High Tech and Metzger and anybody that's selling products in this industry. But the one thing that, as a consultant, that I see that most contractors don't get to see is I get to go back to the projects after a year and go do the 1 year punch walk to determine whether, we have any warranty claims or there's issues with the slabs or whatever. And as you stated earlier, I get a lot of the customers, the owners or the operators will say, oh, well, my joint's failing over here. And I go look at the joint and it's not failing. What you get is you get separation bouncing back and forth. And so I always explain that. I say, what that tells us is that the concrete has shrunk beyond and it's pulled that joint open beyond the tolerance of the joint fill material. And the reason that it's not a failure is that it's bonded well on both sides and it fails at the weakest point, which is not always on the left side of the joint or always on the right side of the joint, but back and forth. So the material is doing its job. It's holding the best that it possibly can. But when you expand or stretch beyond the tolerance of that product, then it's going to separate. And then I will walk them through, life cycles of concrete and how, you get rapid shrinkage as the concrete's curing out. But over a couple of years, as it equalizes to the humidity in the building, you'll get a lot less movement, a lot less shrinkage back and forth. And I can explain that to the customers. And, being and this is probably something you as a manufacturer would struggle with, as an independent third party I'm not getting paid by selling the product or by installing the product, and I'm the owner's rep. It's a lot easier for me to share that information than it is if you, the manufacturer, say the same thing, or the contractor says the same thing. A lot of times the owners will think, oh, well, they're just saying that to get out of liability, or they're saying that to not have to do more work. So I'm sure you run into that all the time. Is my statement on the bouncing back and forth across the joints? Well, let me finish. I say occasionally I'll find one that is all separated on one side and it doesn't bounce back and forth. Typically, not every time, but typically when I take a piece of that joint fill out, what I find is that I'll find a lot of, to your point, slurry or grinding dust, something along the sidewalls of that joint that created a bond breaker. And so then the joint separated, not even because of a lot of shrinkage. It didn't even have the chance to stretch because it was not evenly bonded in there. Is that thought process correct in your opinion?
Spot on. So what we call it leapfrogging when it jumps back and forth. So the two main types of separation you're going to see with any semi-rigid joint filler is adhesive separation, which is separating from the sidewall, and cohesive separation, which is where it splits from itself. So on a properly prepped joint, you'll see both of those. On a joint that was not prepped very well, a lot of debris, slurry, dirt, dust, contamination left down in the joint, what you'll see long stretches on one side of the joint where the material never had an opportunity to bond to the concrete. And as a manufacturer, we can't defend the contractor, the installer, when we see that. But if I see that the material jumping back and forth across the joint every 3 to 4 inches, every 8 to 12 inches, it is fighting as best it can to hold those two slabs together. But the force on the pull on the material is just greater than what the material can handle. So you never want to be on one where if you can just pull the material out, I mean, that's never a good sign.
Right.
But you really want to see it leapfrog, jump back and forth, or you want to see it cohesively split from itself. Because when it's doing that, it's trying to protect the joint shoulder as best it can. It's still a transition strip from one piece of the slab to the next. And if it's debonded from both sides, then you'll get joint filler push down, meaning it's below the surface and it's doing absolutely nothing at that point. That is a failure. When the joint filler has pushed down below the surface, it's not doing any job whatsoever. So no, you're spot on with explaining that. And there's all types of, especially on new construction, you'll see it a lot is where we'll get dominant joints. And that's where a joint activated earlier than the other joints. And you may get, all the expansion contraction joints may have been cut at, an 1/8 inch, and most of them are 3/16. But you may get one joint that's a 3/8 or a 1/2 inch, and this isn't a cold construction joint. It's just an expansion contraction joint that activated early. And as the slab was hydrating out rapidly, you see this a lot in the summertime. You see that one joint take the majority of the movement, and in those sections you will see quite a bit of separation. I mean, and it's obvious when that happens. But no, you're spot on in your description of that. Is if the material has a chance to bond, you will see it leapfrog back and forth or split from itself. And that is not a failure. That's just cohesive or adhesive separation that's taking place. And one of the great things about polyureas, most of them bond to themselves extremely well. So in some of the specifications we see for the retail environment, they have it in the contract where when you bid the joints on the front end, you also bid some extra in there before the grand opening to come back. And any separation that is just leapfrogging back and forth, what you do, we just vacuum that joint out as best we can. You take a bar of soap or some type of bond breaker that you can put on the polished surface there or the finished concrete slab that's not going to cause any damage. And you just you heat up your polyurea a little bit just to thin it out a little extra. And you overfill that over the original joint. You wait your 30, 40 minutes. You shave it flush. You remove your soap or whatever bond breaker you put down. And it looks great, and that's part of the fix. The other option is if there's complete separation or long stretches where it is separated from one side wall, you do a mill and cap. And what that'll do is you'll mill down a 1/2 inch. Make sure you've reprofiled each. You won't remove all the material because you've still got a good bond on one side wall back or forth. You will mill down a 1/2 inch, revac that out, put your bond breaker down, and overfill that joint and shave it flush. So, a lot of retailers understand this is the reality of these rush construction schedules, and they have the contractor bid that in on the front end to say, hey, and then, sometimes you get to come back and there's very minimal, almost no separation, and the contractor has a great day. They made more money on that project. But it's good to see retailers and people start to understand that this is a reality, and preparing for it on the front end and educating the end user on the front end is much easier to address these issues than when they believe it's a sealant that it's never going to separate, because that's just not the reality.
So I want to make sure that I'm capturing you correctly there. What you're saying is that if you really want a successful project, you should have a consultant on the job ahead of time that manages and controls the design, the specification, and the expectations so that the problems don't ever happen. And if they do, there's already a process in place to fix them. That's what you're saying?
100%. The education on the front end gets rid of so many issues on the back end.
So one of the things that I'll share with our audience here, when I get customers, they say, oh, it's concreting. If it were shrinking that much, then it would be cracking all over the place. And I explain, no, that's not necessarily true. The control joints are there to give the concrete a weak point to crack. So you're basically creating a weakened, they call it a weakened plane, but you're basically creating a weakness in that 4-inch or 6-inch or 8-inch thick slab, so that it'll crack in the bottom of the joint versus crack randomly across the surface. And I explain, and this, my family, going back to my grandfather, was in air conditioning. And so one of the things you learn very quickly in air conditioning is, as a kid growing up, is that you have something called an air return. And so everybody sees the vent area in your house in a hallway or in a bedroom or something where you've got this, this big grill. And if you put your hand in front of it, you can feel that it's pulling air from the room or the space into the air conditioning system, and that's how it uses to cool. Well, what I explain to customers is when that's happening, you're creating negative pressure in the space because you've got a constant vacuum cleaner constantly sucking air out of the room and then recycling it through the air conditioning system, but you get a lot of loss there. So the volume of air in a building gets reduced. That's why when you open a door, you feel a rush of the hot air into your face as you're trying to go out the door of your house, because you got negative pressure in your house. When you open the door, all that warm air comes in. And I say, well, when that happens and you're in a big building, the bigger it is and the more conditioned it is, the more shrinkage you'll get. That negative pressure pulls all the leftover moisture that's in the slab, pulls it out and up into the air in humidity. And when it does that, and I can use an example of like a loaf of bread. If a loaf of bread is drying out, what happens to it when it comes together? Well, you see all the cracks and it dries up and then it starts to shrink in really bad, and then it starts to get really hard. Well, when concrete shrinks, all those control joints start to separate because each one of those islands of concrete is getting smaller as all the moisture is pulled out of it, just like out of a loaf of bread. And so that's what causes that stretch. Is that a good explanation in your mind there?
It is, and we see it all the time where we fill the joints. The joints have been filled in these large facilities. They finally close them all the way in, turn the AC on, and 2-3 weeks later, we have joint separation everywhere because it is pulling the humidity out of the air, out of the slab, causing it to hydrate out faster, and then we start to see the separation. But yeah, so on typical, for those that would understand the point of the expansion contraction joints, typically they're cut on an 8-inch slab. They're cut 2 inches deep, 25% of the slab depth, creates the weakened plane, just like you explained. So that concrete slab is cracking. You're just not seeing. It's cracking all the way through every 12 to 15 foot on those joints, and that's why they're cut there. And if you don't cut those joints, really in that first 12 to 24 hours, you'll usually start to see out-of-joint cracking.
A lot of random cracks.
Yeah, it's just random crack that happens at the surface. And that's why the timing of when they saw cut those is very, very important. And kind of talking about the acclimation, one thing that we see all the time, and most people think they're doing the right thing by their crew guys, is when they fill joints in a freezer, in a food storage facility, a fridge or a freezer. A lot of times they will bring they'll fill the joints before the freezer is even installed and running. Or they will have the facility cut the freezer off and bring it up to a more comfortable working temperature for their guys, which I understand completely, to have a better, more comfortable work environment, but you're setting yourself up for failure every single time, because as soon as that freezer, those coolers are turned back on, it's going to pull the moisture out, the concrete's going to shrink, the joints are going to open up, and you're going to have separation. So, these polyurea joint fillers I've personally shot joints at negative 15 degrees. The polyurethane repair products, I've personally been at negative 30 degrees and used products. So they're capable to be used. No one likes to work in that environment, but that is the correct application. There is some education. You got to shave the joints a little faster because they can truly freeze and become brittle and start to chatter. But you never want to fill the joint in a refrigerated or freezer area until that room has been, at temperature for minimum a week or two. To pull that moisture out of the slab and really open those joints up, because if not, as soon as you turn them on, you're going to have separation, and now you're going to have to go back, and once again, if you've got to cut material out, it's a slow, rough process, and you don't want to do that in negative 20 degree environment if you can avoid it.
We did a project, the first one that I made this mistake on, and I never made it again. We did a big quick freeze storage place for one of the largest meat producers in the U.S. And it was a big building. It was probably, I don't know, maybe 350 or 400,000 square feet of floor. And we did all the joints in there, and they had joints, I want to say 10 foot on center. So they had lots of joints in there. And just like you say, it wasn't actually my guys. They didn't bring it up for my guys. They brought it up for some other, for the painting and something else. But they got everything working, got all the massive air handlers in and everything to get that temperature down well below freezing, because they're quick freezing meat, right? And so we did the joints, did the floors, did the joints, everything's fine. Then they got it back down to temp, and literally every joint in the place separated. And the owner says, "Oh no, it's wholesale failure on your part. You didn't do your job right." All this, and we brought the manufacturer out, and everybody agreed with us that we did what we were supposed to do, but it didn't matter. We're going to hold all your money unless you get this fixed, right? So just like you say, we were 15 degrees below zero in there trying to mill and cap joints everywhere, and that's the first and last time that I filled joints above temp in a freezer cooler area, because 400,000 feet of redo was not a fun cost to absorb. But
I can imagine. And one thing that doesn't happen as often, but it did happen to us on over 1 million square foot project in the Northeast 3 years ago when they had record-setting rainfalls, is what does happen sometimes too. And this is, one question that gets asked a lot is, would you use a polyurethane joint filler underneath an epoxy coating? And filling joints under epoxy coating is a little bit of a damned if you do, damned if you don't. On an older slab, when you're putting epoxy over it, if it's been allowed to breathe for all these years and now you're putting this coating over the surface, if there's some, water tables high or a lot of rain, groundwater is on and water underneath the slab, that concrete will start to pull the water in and it will swell. And you will actually get what we call the speed bumps underneath in the joints, where you get joint filler protrusion. But it does, on rare occasion, happen on floors that are not coated as well. And that did happen to us, like I was saying. It was over 1 million square foot project. And, the GC, the old GC, the guy that was on there was probably 60-something years old. And, he told me he's been pouring concrete 30-something years. It doesn't swell for anything. It only shrinks. And he said, "Hey, the joint filler's sticking up. We want the guys to come in and reshave it, or to shave it or replace it." And I said, "Well, what happens is if we shave it right now, and once this rainfall subsides and things get back to normal temperatures, the joints are going to open up again. And then now when we shave it, when it's high, it's going to be very concave when it settles back down." And the GC basically, same thing you were saying earlier. The GC thinks I'm the manufacturer. I'm just there to make some BS reason of why this is happening. And he said, but they agreed to wait a couple months. I think it was in June when we walked the job site. And it was one of the few times I've ever had a very nice apology email from a GC. And he basically said, "I'll be damned." He said 3 months later, 2.5, 3 months later, the joints are right back to what they were. They look great. And we're glad he did.
If we had shaved them, we would have been screwed.
Yeah, if we shaved them, we'd have had to go back and mill and cap them and created way more work for ourselves. So it's not something that happens very often. It's nowhere near as common as the exact opposite of that, what we've been discussing of the separation. But it is something that does happen on occasion, and it typically happens when the water table is very high, or you have just abnormal amounts of rainfall. That can happen, and when you have high humidity, it can happen as well. But it's much more rare. But it is one of those things that with a semi-rigid product, they can get squeezed by the joint filler, and squeezed by the concrete and cause it to kind of bulge up above the surface. But the contrary to that is if you did something that was more brittle, a harder joint filler, it would crumble in that situation. So, there's no perfect product out there, but the polyureas they're very versatile and can handle quite a bit different applications.
Well, I have one more question on polyurea and shore hardness, and then I'd like to transition and talk a little bit more about kind of the future or other products and kind of what you see coming down the pipe. But my last question is, so over years of being a consultant, which now I'm in my, I think, 12th year of owning our consulting firm, and looking at all these jobs, when I first started, and as a contractor, I would typically install the 80 shore hardness product because it was easy. It was easy to install. Obviously, you guys make more of that than the other grades, so typically easier to get. And honestly, from a crew standpoint, it's easier. It sets up a little bit faster than some of the softer materials, so we could shoot it and then shave it and then move on through the job. And then maybe, waiting, the difference of 10 minutes doesn't seem like a lot, but when you're doing a 500,000 square feet floor, that can add up into a significant amount of labor time just sitting there waiting on the material to get set up. So as a contractor, I would install the 80 shore hardness product typically. What I started to find as a consultant is when I would go back to the projects a year later, not on industrial jobs, because I'm not talking about manufacturing industrial with lots of forklift traffic, never touch any of that. But when I'm talking about clothing stores or schools or restaurants, or even a lot of the grocery stores, when we would install the 80 shore hardness product, I would find that I would get a lot more joint separation as normal shrinkage occurred than if I installed a 60 shore hardness product. And I think it's because, and the way that I explained it to customers and contractors too, is that the 60 shore hardness has 40% elongation versus the 80 shore hardness having 20% elongation. And that little bit of difference, well, it doesn't necessarily seem like a lot, would be enough in a lot of those cases to hold that joint closed. And a lot of those customers, let's say you're a restaurant or a grocery store, it's actually more important that your joint stay closed than it is that it stay flush and flat with the surface. A little bit of concave is okay if it's closed. Between the liquid spills, grease in restaurants, and then the constant cleaning that you get a lot more in a grocery store, for example, than you do at a manufacturing plant, all that extra water going into the joints that were separated, even if they're bouncing back and forth and adhering properly, that excess moisture going in, I found would cause failure of those joints a lot faster. And the customers were more concerned about the joint staying closed than they were about the joint staying perfectly flush. Is moving from an 80 shore hardness, like you would do in an industrial facility, to a 60 shore hardness in a school or one of those lighter duty customers, is that a good approach, or what are your general thoughts about that?
Yeah, that's the right approach. And you want the product with as much elongation as you can put in the joint when you're not going to have, heavy cart or heavy fork truck traffic. But it also, the one thing you have to always keep in mind when you start going too soft, because in the past we made 40s and 45 shore hardness, but they become a trip hazard to women in high heels. That's a concern on a wider joint. So you have to make sure that
because they concave too much.
Correct. Yeah.
Right?
You like to be take a real soft seal.
I feel like I need to say something here and appreciate that you look out for women wearing high heels. That's been my 2 cents worth.
Yeah, no, and that's one of the big selling points of polished concrete versus with the big retail grocery chains in the country is their slip falls liability and insurance is way down versus tile. And I think we probably know a lot of the slip falls are probably people looking for that opportunity, those lawsuits. So when they have a piece of damaged tile, it's an easy way to set a store up and basically, claim that you had a slip fall accident. So that was one of the big reasons that, the green side of polished concrete, there's a lot of, positive advantages of the environment, the long-term maintenance, but also it drastically cut back on the slip fall lawsuits that these grocery stores have dealt with. So that was one of the concerns early on is, that the high heels of someone wearing those, and if they step into a joint, if the material's too soft and it goes down in that joint, well, it's a very easy opportunity to hurt someone's knee, hurt someone's ankle, or worse. So that's the one thing when you start to go so soft on a joint floor that you really got to watch for the trip fall hazard. But yeah, you're right. The softer, I think our 65 is rated at 220, 230% elongation versus 150 to 170 on our 85. So there is a noticeable difference in elongation and flexibility. And you want to find that kind of perfect line if you can. If we could find the perfect product, believe me, I'd be screaming from the mountaintops about it. But that's the right mindset to have, is in those environments where they're not going to have near as much industrial abuse, then yeah, you want the product that gives you the best chance to eliminate as much separation, whether that's cohesively or adhesively as possible.
Okay, so perfect. Thanks for sharing that. So I want to transition a little bit now. I know you guys do a lot of other repair products, and we specify them and use them a lot for spall repairs, which are spalls, for those listeners, is typically a small diameter divot in the concrete So maybe it's 2 inches or less considered a spall, right, David?
Yes, sir.
So 2 inches or less. Sometimes this can be where a framer shot a base plate for a wall straight across a doorway, and then instead of pre-measuring for the door, they'll just put the whole track down all the way, and then they'll come and cut where the door is, and then just rip the track that they shot into the floor out, and where that nail was shot in. When they when they yank it out like that, it breaks the concrete around it and pulls out almost like a little miniature pond, with shallow sloping edges to nothing and then a deeper point in the middle. Or sometimes it can be caused by a tool drop or a material drop. Somebody, drops some steel, or, a hammer falls off of a ladder and hits the floor. Those make small spalls. So your product that you use to fix those small ones is TX3, is that right?
Yeah, so we have our line of Spall TX products, and then we have our Spall RX. So very similar polyurethane technologies. The RX does have some solvent in that. It's not a 100% solid. It's an excellent product, but the odor it makes it not ideal for a lot of retail applications because there is an odor.
Open store.
Yeah, and then the TX line is 100% solid, and that's our most common sold repair product. And it's got a little bit of an interesting history. So the reason behind the TX, all the early polyurethane repair products out there, and the polyurethanes, just so people understand, think of like a bowling ball. Most of them cure somewhere in that 4,000 to 5,500 compression PSI. It's pretty common, so very, very hard plasticky like material. And that's kind of the best way to relate it to someone to think of a ball. It's almost damn near indestructible material. These polyurethanes versus other mortars and other things that are out there on the market, and kind of what Hi-Tech, what we specialize in, is all these one-to-one products. They're very quick curing. So quick curing is great. The regular Spall TX, you can drive a fork truck on it in 20 minutes. You're ready to hand grind it in 12 to 15 minutes, depending on the temperature. But any product that cures that quickly, you have limited working time with it. So Rick Swanson, years ago, came up with, working with our chemist, a product we call our TX3. So it's just like our regular TX. It's 100% solid polyurethane, but we were able to slow it down enough that you can hand mix this product. And the idea behind it was, this was before Rick knew anything about polished concrete, is he had contractors that were doing joint restorations in big industrial facilities. And while the TX line is a great product for that, it's very durable, cures very quickly, you would either have to pump it through a cartridge or through one of our, at the time we made this, we didn't even have our joint pumps yet, but one of our competitors' joint pump, you would have to pump this product through, and it's a very high cost to do it that way. So Rick wanted a product that you could hand mix, and by hand mixing, you could mix dry, all-purpose sand, and over the years, we've incorporated mixing any dry cementitious product, aggregate glass, doesn't matter, you can mix for high
grinding dust.
Yeah, grinding dust, as long as it's dry, you can mix that in, and it raises the compression strength. And one of the other things that it does is it raises the most hardness at the surface when you do a cement or sand mix with it, because these urethanes, while they're high PSI, I think ours are right around 4,500, depending on which product exactly that we're talking about. While it's got a high compression strength, its Mohs hardness is only around a 2.5 to 3. So they don't polish very well on their own. So when you go to on a gloss reading, you may get like a 14 to 18 gloss reading because the Mohs hardness is not hard enough. But when you introduce sands and aggregates and cements, you can raise that Mohs hardness up to a 5 to 6. And now you can get these products when you have a spall on a polish repair project, you can mix 2.5, 3 parts all-purpose sand that's dry, true PC, any of these polishable overlays with aggregate, you can mix basically 2.5 to 3 parts of those with our TX3, and you make a thicker, basically mortar that you can put down in there into your spall or your crack or whatever you're repairing, and you can grind it 45 minutes later, and that will look just like concrete. We can make it blend completely in with the concrete, and it polishes and it takes dye. So these polyurethanes, back to kind of what Rick created it for, was for joint restoration, to give a contractor more time to mix sand, which the sand brings up the compression strength of the joint reconstruction. It also drastically cuts the cost of the material for the contractor. And These products, while, we call it TX3, and that 3 stands for 300 seconds of working time, is roughly what you have with it. And that's going to vary if you're doing a mix in a bucket versus if you're doing a grout coat. When it's thinner material on the floor, you're going to have a little bit more working time with the product. But it allowed us to have a
Can I pause you for 1 second and do a clarification for our audience who doesn't know? So I talked a second ago, we talked about spall repair. So you're repairing those small holes. So if you don't put in something like a sand or a grinding dust or something like that, what you end up with is the polished concrete around has tiny speckles, effectively, which are sand aggregate, and maybe even some of the larger aggregates barely being exposed to the surface. And then you get to this repair, and although it may be using some of the 500 color variations, it may be similar in color to the cement paste around it. Because it has no speckles, it looks plastic. And so it's almost like somebody, dropped a dollop of plastic onto the concrete. Well, then it stands out and jumps out to you. But if you mix in the material, then it blends, because you've got similar speckles in the repair that you do in the area around. And the other thing that you mentioned that I wanted to just clarify is grout coat. So when you're dealing with concrete that's got a lot of pitting, pinholes. So like if you have a slab that's got a high fly ash content, for example, and then that goes through construction and it's gotten rained on a few times, and then it's gotten cleaned, it's gotten ground and polished, and then cleaned a bunch more, you'll end up with little small sand particulate rollout or small pinholes. Or sometimes you'll run into slabs that have craze cracking, little small fine surface cracking that doesn't affect the integrity of the slab, but it's also not smooth at the surface. You can take a thin, viscous, a lot more liquid fluid repair material, and you can spray it out onto the slab, and you can squeegee it around so that it fills in the little tiny pinholes and cracks. And then when it sets hard and it's polished, those are then filled, and you can't really see them or feel them, and so they don't have any abrasion characteristic. So you stop those, for lack of a better term, those little micro potholes in the concrete from growing just like a pothole in a road would with traffic and cleaning. You get to stop that with a grout coat. Is that a good explanation, David?
Great explanation. And this is something that, not because I'm a manufacturer of this product, we didn't develop TX3. Rick did not develop it as a grout coat. What would happen in the past is guys would be on a project, they have a lot of pitting or something like what you were just explaining, and they would use an epoxy product that they would trowel out over the floor like a clear epoxy. But that would shut the job down for 6 to 10 hours, depending on the product and temperature, and they would basically be done for the night. No one could walk on it. So customers figured out they could hand mix our TX3, trowel it over the floor, and you've got 6 to 8 minutes while you can trowel it out on the floor, and then you can grind it 35 to 45 minutes later. And I'm passionate about this part of polished concrete because I still don't think that grout coats, whether it's ours or competitors, they get utilized as much as they should. I have never to this day seen a floor that cannot benefit from a grout coat. The grout coat raises the gloss readings on any floor that it's applied on. A really rough floor, it can raise gloss readings by 15, 20 points. The average floor, you'll probably see a 5 to 8 point higher gloss reading with the grout coat. And we all know through densifiers, we all want to harden the surface as much as possible, and we want to get as much pitting and pinhole at the surface. We get better reflection, but we get way better abrasion resistance, long-term wear for polished concrete. And that's where grout coats, I don't think, get celebrated and discussed enough, is that they really cut down on abrasion from just regular foot traffic, cart traffic, anything that's going over. The tighter we get that top surface closed off, the less abrasion we're going to have. And these polyurethanes, like I said, are damn near indestructible. I mean, they will hold up better than the concrete around them. I mean, they really are hard. Regular fork truck and foot traffic is really never going to have any real effect on these urethanes. Think of it, once again, a bowling ball. It's a pretty indestructible material. So something that could be utilized on every project. And one thing that I love to do when we're doing trainings is when I first started doing trainings, came over from HTC to High Tech, I was always so concerned when we grout coated the floor, I wanted to match the color to the floor that I was polishing on the demo. We're doing a 10 by 10 demo. There's 30 to 50 people, the contractors in this room watching us. And a lot of them say, well, it doesn't really look like it did that much. And then one day I just decided, okay, I'm going to do it in bright pink. So I tinted both sides of the product and did it in bright pink at a facility that I had done probably 20 demos at before. And it blew everyone's mind at how many tens of thousands of little pores in the floor that you could see this pink color in, that it stayed in the floor and it was doing its job. But when you match the color, you don't see that, you don't understand it. But that's the point. You're not supposed to see it. But I think until you really illustrate it in that way, a lot of people really, truly fail to understand how many little mini pinholes are in that floor that are not microscopic, but they're very, very small. And it makes a huge difference. So not a product we ever intended as a grout coat, but I don't know, obviously I don't know the numbers, exactly what my competitors are selling, but I'm very confident in saying that the TX3 is the most utilized grout coat in the decorative concrete industry in the U.S. I'm pretty confident in saying that.
Great. Well, okay, so we've kind of addressed spalls, and we've addressed grout coating and small cracks. We've addressed joint fill, which also can work for larger separated cracks. What's coming? What's the next evolution in your particular sector of the market? What's the next thing that we should be looking for as this industry continues to grow and expand?
I think you'll see further advancements in the current products. Obviously, with the OSHA initiative 3 years back about dust, if they're trying to raise the standards, obviously it's better for our industry. It's better for employees out there, the guys in the field. So we're seeing a lot more of the wet polishing take place. So I think you'll see us chemical manufacturers develop more products that can have moisture tolerance or actually benefit from moisture. So I think that is probably where you see on the chemical manufacturer side, is we're just seeing this wet polishing take off, and there's so many benefits to it. But as a polyurethane and polyurea manufacturer, we didn't love it when we first heard of it, but we see the benefits of it, not only in the quality of the floor, but for the health of our industry. So I think you'll see more advancement in that. We'll always constantly push as much, continue to test UV stability with these aromatic polyureas. There are products out on the market, and we toy with them and test them all the time. We're always with aliphatic technologies. The problem is, and one thing we talked about earlier, is the U.S. market, how we don't do full ag exposure. We're much more on our polished decorative side, typically do an 80 metal cut or a transitional and run up. We're very cost competitive, our industry here in the U.S., and that's where the aliphatic technology that's already in existence and that we're continuing to work on becomes a little bit of a challenge, because there is a much higher price point on the aliphatics. So for us in the future, I think you'll see more of the UV stability. We're currently working on another version of our TX3 that's a thinner version without a solvent. We're looking at the different possibilities that are out there to continue to make that product as low viscosity as possible. And the reason we're doing that is you can make better polishable repairs. The thinner the viscosity, the more cement and aggregate you can pack into that repair. The ease of use, the grout coating application, the lower viscosity products do great on grout coats. So just constantly trying to evolve. And one thing we haven't
they do great because you can get more material into the smaller pinhole or smaller cracking. Is that why it does better?
So in a grout coat application, it just penetrates deeper. And what you have with 100% solids product like our TX3 is when you start getting down into the really fine pins and pores, I apply it with a steel trowel, just a hand finishing trowel. I like to be down my hands and knees, and I like to angle that trowel to put down pressure on the TX3 as I'm troweling it across the floor, because there is a surface tension in those small pinholes. And the TX3 is about 190, 195 centipoise when it's mixed. Similar consistency to like a whole milk is kind of, so people have a reference point of the viscosity level of that product. But our RX product is right around 20 centipoise. It's almost water thin. So it penetrates. Surface tension is not an issue whatsoever for the RX product, but we have to overcome the odor that a lot of people, that pushes a lot of people away from it. So on the grout coating, the lower viscosity helps it penetrate into the slab better in those small pores and break the surface tension. On a polishable repair, when we're mixing sand and cements, it saturates the sand and cement so much better that where our TX3, I never recommend going more than 3 parts sand and cement to mix TX3. With the RH product, you can go 4 parts sand and cement, so you can really get a beautiful polishable repair. But once again, the odor is a setback. So we're looking at different ways to lower the viscosity. And the challenge of all these products that are out there when I work with our chemists is, they say, David, what do you want? So I'll tell them my wants. Like, all right, you can have 2 of those 5, because every time you change something, you get something new with the product, you have to give up something else because you have limited working time with these products. And one change always has another effect somewhere on the product. So we're constantly testing. And I don't know if it's a question you plan to ask, but one thing I would love to discuss on this for those that are listening is the last 12 months and what all of us chemical manufacturers have gone through. It's been hell, to say the least. That deep freeze that hit Louisiana and southern Texas in February of 2021, we're still dealing with the impacts of that. So when you kind of ask what's new and what's on the horizon, we were working on a lot of stuff before that happened, and a lot of these raw chemicals are just not available. They're in such tight supply right now that it's really prevented us from launching some new products or continuing testing on a lot of ideas and things we were pretty far along on. We were seeing some great results, and it has become just near impossible. And things are starting finally to improve, but we're 12 months into this, and I'll gladly go into more detail of kind of the timeline if you want me to, but it has been unlike anything I've ever seen in my career.
Well, rather than going into the entire thing, just as we sit here today, which we're February the 18th, I think today, something along in there, mid-February, what products are affected the most where you're backlogged or you just don't even have the ability to make them right now due to supply chain shortages or backups?
If I get all my allocation of raw chemicals I've been promised from our providers in March, we will actually have all of our materials stocked and some excess sitting on the shelf. At one point, that's something I didn't know when I'd be able to say again. At one point back in probably August, September, we were well over 50,000 gallons back ordered on our PE85 joint filler. We were 20,000 gallons back ordered on our Spal TX3. It has been a challenge unlike any other, but things are almost back, and I think you'll see that the isocyanate market in the U.S. is still extremely, extremely tight. Some of those components we're still seeing some price fluctuations, and it's the classic supply and demand. Almost all the major raw chemical providers in the U.S. are now off of force majeure. Meaning that's just a legal thing that they had in place when all these issues happened, that they would have to fairly operate, and they can't give special treatment to any one customer. They have to kind of divvy it up by percentages of past purchases to be as they can be. There's still some sales allocations out there on some of the raw chemicals, and but it is getting better. So to answer your question here, about 2 weeks we should have every single product that we provide sitting on the shelf. But it has been a heck of a hole to pull ourselves out of, and I think our competitors would agree. And it's almost comical when we get some of these products in, and then buckets are almost impossible to get. Mixing nozzles,
right?
Like labels for buckets and cartridges, something that I would have never thought would be a challenge. And what we've learned is there's so many things based off the oil industry. When that freeze hit, things were already very constrained, and then when that freeze hit last February, it really sent a shockwave through our part of the industry, through the epoxy world, the plastics, and it's obviously everyone sees it on the news and hears the stories. I mean, it's affected the automotive industry. I don't know if there's an industry that's been untouched by this, but the signs are it's getting better. But we're definitely not in the clear. We're probably all thinking probably end of Q2 before things are truly back to where the lead times on all these raw chemicals and products are back to what they were before last February.
Well, I'm very excited to hear that. So, David, I want to thank you very much for this. Has been an awesome interview. Lots of information. I think will help anybody who wants to listen to this. How do people get through to you if they want to be a customer or they want to try to understand more about the products that you offer? Maybe they got a program, or maybe they just got they got some projects that need help and have been looking for a supplier to help. How do they get through to you guys? Do you sell through distribution? Do you sell direct? And, what's the best way for people to get through to you?
Gotcha. So we're primarily a direct sales company. We have 7 different guys out across the U.S., location in Southern California, right outside of Los Angeles in Ontario, California. We have a Dallas facility, which is very new to us, and then we have our Nashville, Tennessee facility. So the website is Hitech, HITECH, polyurea, POLYUREA.com. We have all the contact information for all of our different reps, our different offices. People can reach out to me personally. I actually prefer that, try to have as much interaction with our contractors as possible. So anyone can reach out to me directly at my cell phone, which is 615-756-8008. But anyone on our team is glad to help. We're very quick to get out on a job site, bring out our equipment, our polyurea pumps, our shavers, our different materials, and do either trainings in your shop or on job site. We're glad to do any of that at any time.
For the listeners who don't want to bother you on your private cell, what's your email address?
Jerome, DJEROME at HTSpoly.com. Jerome at HTSpoly.com.
Perfect. And we'll put that information in the show notes, and we'll go from there. Thank you very much, David. I really appreciate it. Really enjoyed the conversation.
I enjoyed it as well, David. Thank you so much.
Have a great day.
Thank you.
That's it for this episode. If you like this episode of Foundations, be sure to head over to our website, expertconcretetraining.com, for training videos and content tailored to your needs, interests, and job role. You can find topic and/or document links from today's discussion in the episode notes on our website. We appreciate your feedback, questions, and support. For specific job-related technical questions, please go to the Experts on Demand tab at expertconcretetraining.com. To suggest a topic for discussion on the podcast, please email info@expertconcretetraining.com. On behalf of David and myself, thank you for listening, and we look forward to hearing from you. The hosts and guests presented within this podcast have experience working with concrete, allowing them to provide insight concerning various construction conditions that might differ for the listener. The content and materials, as well as the products referenced within this podcast, are presented for general information only and are not presented as professional advice. Reference to specific products or service providers does not constitute an endorsement nor illustrate that a particular result can be achieved. Listeners should take care to follow all product manufacturers' warnings and instructions and understand all applicable safety codes. The opinions, views, and statements made within this podcast are those of the hosts and guests only. If you have any questions, concerns, or issues on your project and need additional support, please reach out to your manufacturer or consult with a firm like ours for specific and direct assistance with your particular needs and concrete.